Everybody, I'd like to introduce you to Eric Oestrich.
All right. So this is going multi-node. I'm Eric and work at SmartLogic. This is our link, smartlogic.io. I'm Oestrich on GitHub and Eric Oestrich on Twitter. So a brief overview of what the talk is going to be. So first we're going to find out what this thing called a MUD is. Then we'll look at clustering, leader selection, making stuff span the cluster, and then some problems I encountered. So this is going to be looking at a project called ExVenture. This is exventure.org. This is an open source multiplayer game server that's text-based. We'll also be seeing something called Gossip. This is gossip.house. It's a cross-chat network, cross-game chat network for text-based games. And then if you want, you can go to midmud.com. This is my hosted version of ExVenture. You can go sign in, poke around, and find out what these things are for yourself. So it's midmud.com. So first off, what is a MUD? So a MUD is a multi-user dungeon. It's a text-based multiplayer game. Started in the late 70s. If you've played World of Warcraft or EverQuest, think of that, but strip all the graphics away. So we can take a peek at what this looks like. So this is what you'll see when you get to midmud. You can click the big Play Now button. So we have a nice little ASCII art at the top, right? So then we sign in. So you kind of have the world around you. So this is the room we're in, some descriptions to help with your imagination of what this place looks like. You can see there's a town crier here. He's trying to catch my attention. And if you've played larger games, you can see this little exclamation point. So he's got a quest for me. Unfortunately, I've already completed that quest, and that doesn't go away quite yet. But yeah, so we can, so you do commands. Let's pull this off so that you can see see what I'm typing, because it's in the bottom corner. So so we have a little panel to type in what we're going to do. So I'll say, hello, big Elixir, right? So then I say to the room that I'm in, hello, or I guess just the big Elixir, I guess is what I typed. So then you can do emotes, right? So it'll show Eric dances, right? There's some built-in ones, so I can wave at people. So then we can go explore the world. So I'll type south. So I move south. So now we're going to go try and find. There's a goblin somewhere out here, and we'll go find him. You can click these as well. So we found him. So we're targeting the goblin. I can go ahead and cast Magic Missile at him. So I shoot a bolt of energy and deal 14 damage. The spell is ready again, so I can shoot him again. So he died. He dropped gold. So I can say get gold. So I picked up the gold. You can see what's in my inventory. Let's pull this out a bit. Right. So then I can go west. He respawned. So we'll just do the bigger one that'll kill him right away. So we can pick up his gold. We'll go north. Now we can go to a general store. So this is Lucy. She greets you when you enter. We can see what's in her store. Right, so we can buy an elixir, right? And then we can drink that elixir. And that'll heal my skill points. Not that I needed to, but so that's the basics of it. The other thing, there's a client called Mudlet. So this is where this is using Telnet. Oh, I gotta sign out first. So this is using Telnet. There we go. which is just raw TCP sockets with some other special fun things added. So this is a full-blown local client. You can do scripting and all that fun stuff. And so yeah, we can do the same kind of walking around and whatnot. So this is primarily the interface for most other games. Let's say no. Okay. So that's a mud. Some games that you might have heard. These were two popular games in the late mid '90s. One called Discworld, which is based on the Terry Pratchett novels. That one's still running. And another big one that was for BBSs was Major Mud. This one is no longer around, but there's various clones kind of everywhere that are pretty popular. So into ExVenture. So we'll go through the supervision tree briefly. So we have the top level application, ExVenture, then the cluster supervisor, some Raft, which we'll get into, the Ecto repo, the web supervisor, a game supervisor, and then Ranch, which is what does the telnet stuff. If we zoom into the game supervisor, we can see the session registry, which is for tracking where players are. It's sort of similar to the Elixir registry, but with some tweaks. Some game config, all the kinds of caches for items, skills, all kinds of stuff are just local caches. A session supervisor, which is where player sessions pop into, and then the game world. If we zoom into the game world, we'll see there's a world master and a zone controller, and then a bunch of zone supervisors that just get added for however many there might be. If we zoom into the zone supervisor, we'll see a zone. A zone is a grouping of, so it's this full thing. So this is a grouping of rooms. So it's a way to logically separate the world. So we have a bunch of rooms, which are the basic block of the world. A supervisor, and underneath it is the rooms. NPCs, also non-player characters, have their own supervisors, so they're hanging out in whatever zone they're supposed to be in. So this is the starting point for ExVenture. So everything assumed a single node. It was very heavily geared for that. I was using Elixir registries, lots of caches on ETS tables. Everything is stored pretty much in the world, or in world processes. So it wasn't set up to be distributed. So there's two paths forward. I could do an umbrella app, or make it a single application that ran on different nodes across the clusters. I'll call out Aldrich again. So I started thinking of doing an umbrella app, and then he said, why? And I was like, I don't know. I don't really have a good reason. And basically the reason was I didn't want to deal with leader selection. However, that's what I ended up doing. So we went with a single application that's cluster aware. So let's see how we get there. So this was, so first you got to start with just making nodes connect to each other. So this will be two entirely independent nodes that run the full application. So the full world will be in both. So join them together with libcluster. This is a really great library. Definitely give it a go. So this was pretty much all you have to do. I set it up with the EPMD strategy. We saw Kubernetes earlier. There's a few other, I think, that you can do. So this is just a local EPMD and our two nodes. You start them with different short names. That's what that S name is. So World 1, World 2, they're started, and they're ready to go. So you can just kind of see that the two different nodes spinning up. So next we have to pick a leader. So I went with the Raft Protocol, which is a consensus algorithm. There's a few other things in the Raft Protocol, but I just went with the leader selection. So you can kind of see what happens here. So this is, Raft has a pretty great visualizer for how this works. So here's our 4 nodes. You can see the different timers. These timers are counting down to when it will try to say, hey, pick me as a leader. So they'll count down S21, so it'll say, hey, vote for me. It sends out packets. And then all the other nodes, if they haven't seen a leader being picked, or if they haven't picked a leader for the current term yet, they'll vote for them and send it back. When that when at least half the cluster has voted, it will win, and then just say, hey, I am the cluster, or I am the leader. So that's what these are going out. And then it just does check-ins, packets saying like, hey, I'm the leader, I'm the leader, I'm the leader. So we can watch this here. So this is a visualizer, so we can see it in action. So it looks like one might win, maybe. So they'll send out packets, and we can, ooh, it's a race. So yeah, so then number 5 won, and then it's just sending out its packets to keep alive. We can shut it down. We'll speed this up a little bit. So then there's also timers on all these other nodes to then still like keep the cluster alive. So then this is the number 3, number 3 just won. We can bring this one back online. It will try and vote for itself again because it's just started until it sees that assert leader packet come in. And then so it catches back up with the cluster. So, right, the way this, so each node starts up, picks a random amount of time. I have it with 500 milliseconds plus a certain amount of time. I think up to another 500 milliseconds. So then whichever node picks the lowest number will try and vote for it, or assert itself as a leader, or pick itself as a candidate, and then they'll vote for it on the cluster. Once the majority is picked, then we start the world. So the leader in ExVenture starts up all of the processes that are very stateful. So this is the world cluster, everything in that game supervisor. The zones get spread out across the cluster, so it looks to see what zones should be online and what zones aren't online, and then spins up the zones across the cluster. As part of this, I pulled that out into a library called Squabble. So if you want, you can go ahead. It's Oestrich/Squabble. This is a simple leader election. One thing, though, I do want to point out, it's only been tested on a low-traffic production, so it may not work on your production, but love to get it there. So these are the callbacks. So you set yourself as a Squabble leader behavior, and then whenever a leader is picked, we'll know what term it was. You can do whatever you want. So for ExVenture, we start, I do the rebalancing of the nodes, or of the zones across the cluster, and then you'll know when a node goes down. Forget why I actually needed that, but there was something. So the other thing is, why do you need a majority of the cluster? So this is to prevent a net split. So that way you can have, I have three nodes for mid-mud. So that way if one of them dies, you still have 2. And you probably want to try and keep it odd so that there's never like a 50% of the cluster is online. It's always more than 50%. So this will prevent net splits and whatnot. So yeah, next we went with removing the local registry. I just went the simple route and just switched via Elixir registry to global and then whatever. This is not necessarily recommended for everything because the global registry at certain volumes of work may be too slow to replicate across the cluster, but this works perfectly for what ExVenture is doing because it just starts everything once and then just is kind of done, more or less. So there's not, if you're doing like thousands of new PIDs per second that's registered on the global registry, you probably want to look at something else. But this worked great for me, so I went with it. Next, we have to span the cluster. So these are updating the caches across the cluster. So instead of just keeping it on your local node, when you do an update, then you want to push it to the other nodes. So yeah, this uses process groups, PG2. This is the one spot that I'm not super sure about, and if you know something, let me know. So here's how that works. So the game cache, so this is games.items. So it starts up a PG2 group. You always have to just try and make the group. If it exists, it doesn't do anything, so you just try and make it. And then afterwards, you join the group. So that puts your PID in the group. PG2 is also really small. to look at. So I definitely suggest it's like 400 total lines it's unfortunately Erlang, but yeah, definitely give that a look. So once that's started up and your process is part of it, this is the client side of it, so where you have your like gen server calls and whatnot. So whenever I insert a new item, we can get the PG2 members, and then you just loop over it. So the one thing with this is between these two, that might have changed. So I've had that happen a few times. So this is kind of the parts that I'm not super confident on. Yeah. So all right, on to problems encountered. So because we're now going across the network, there's a lot of issues that might happen. A previously stable call is no longer stable because you're going across the network. Someone might snip the wire, and then you're super unreliable, right? So you just have to kind of be ready for that. I dealt with this through circuit breakers. So if something happens where the website is up but the internal world state is down, this is what you'll see as a client. So this happens, these two messages are pretty much at the exact same moment. So it tries to load what room you were supposed to be in. It sees that it's down. The process crashes and then tries recovering, and then will slowly back off. So this first one's pretty quick. The next two, you'll watch it go doot, 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 until it finally gives up, and then it just says, hey, the world's offline, come back later. I can't help you. So that's circuit breakers. And then I have things that should happen at most once. So these are things that are related to Gossip, the chat service. So each node has a WebSocket up to the central server of Gossip. And when a new message comes in, we only want to have that happen exactly once, or at most once, so that the code that's dealing with Gossip will see if it will say, hey, am I the squabble leader? And if I'm not, then I just don't do anything. Because otherwise, a new message will come in and you'll see it repeated 3 times, or for each node that you have connected. And that goes reverse for pushing out. So when you do a local channel talk, you don't want to have it span due to the same duplication, right? So only the leader nodes should handle this. And then for some fun extra things, I did some performance tweaks to go from 230 connected players for my local ExVenture server all the way up to 3,500. So the first step was a single process was being overloaded by messages. The room process became a bottleneck. It was acting as a message bus of sorts. So when anything you did to anything else in the room, so like the says, the emotes, moving in and out of the rooms, all of those were routed through the room process. And as more people started joining and the world was small enough so that everyone was kind of bunched together, that room process could not keep up, and then eventually just started crashing because the queue times were too long for looking into the room. So fixing that, I added a side process that all it does is fan out the notification. So anytime a new notification into the room happens, it sees who should get it and then just casts it to its side process. And then that way it can just keep moving. Yeah, so that went from 230 to 600 current connected players. The next step was what I was passing around was way too big. The session registry, anytime you update it, like you leveled up, you moved a room, whatever, it updated its local registry. And so that was pushing around a humongous ecto preloaded struct. So it was what class you were, what race you were, all your skills, all kinds of junk that was just in there that the local process for you cares about, but no one else cares about it in the cluster. So it was being naive about it because I didn't need to care yet, right? So I was just pushing that there and dealing with it later. So eventually around the 600 player mark, that process just fell over because anytime it got a new message, it had to look at this huge stack of data that was just too much to look at. So it couldn't keep up with that. So the way forward with that was to anytime a user tried casting itself around or calling it with itself. It just simplified it drastically. So it's what's your ID, what's your name, and then a bucket of extra data, like maybe the class name that you are or the class ID, kind of taking this huge piece of data and shrinking it way down to a small amount of data. So that doubled it to 1,200 connected players. And then finally was the continuing with that theme. So that was just for updating the local registry, but we're still sending all of these my user struct across for any cast through anytime I do anything in the room, that gets pushed over there and then spun out to everyone that's in that room. So that might be, I have my huge struct casted to the room, and then it copies it to 100 other processes that are also in that room. So we just did my, I don't know, 10 kilobytes of data times 100, and then that's also, everyone is doing that because these are bots that are moving around, so that's just like huge amount of data that's being copied around. The most interesting fact here is I ran out of room at 50 gigabytes of real RAM. My desktop has 64 gigs, so it was really mind-blowing to run out of RAM on that thing. Yeah, so then that just did the same simplification, and that pushed it from 1,200 to 3,500 players, which was pretty cool because this was approaching the level of like what a WoW shard would have. So like each World of Warcraft has different servers that you could pick, and like each one kind of has it like 3,500 to like, I don't know, 7,000 to like 10,000 or so. So it was really cool to be like, ooh, I'm like approaching this thing of like what a commercial server would be doing. So I was using Prometheus and Grafana as well. So this is the fun screenshot of 3,544 concurrent bots on my desktop. So I thought I would be satisfied with that, but then I wanted to see how much further I could push it. So then this ended up stripping out some functionality to just be like, how crazy can I go? There was a few spots that were touching the database too often. So like every time you moved, they were trying to see if there was a quest, be like, oh, you're supposed to go here. So do a database check. It would save, each process would save its state way too often for the amount of players that are that this was at. And so this got me to 7,100 concurrent players on the same server. Yeah, so this was where like I approached that, like this is how many a WoW server has, like 7,100 players. Was really exciting. As another part of this is that actually I was able to add a new bot every 300 milliseconds, I think, versus before it took, I don't know, an hour to spin up to that 3,100 players. So by figuring out like how there's too much database checks and whatnot, and like seeing like where the bottlenecks were, it was pretty crazy to like turn on my local machine or turn on my local telnet's like bot network, and then just watch it go from like 0 to 1,000 in like 5 seconds. So yeah, so this was the specs. I was a Core i7 6700K. It's like 3 years old with the 64 gigs of RAM. And now we'll get to see some of the clustering stuff in action. So here's my 3 nodes, right? So I have the top one. So this is World 1 up here, World 2, World 3. This is using traffic. So we're just load balancing across all the 3 nodes. Right, so that's what we were poking around before up here. Someone was apparently trying to do something that would send me a notification. Right, so we can see debug info. All right, so I'm on World 1 right now. There's my PID. We can see the squabble information. So World 1 is the leader. Down here we have 2 followers, World 2 and 3. So yeah, let's go kill one of these things. So we're up here on World 2 or on World 1. So let's kill World 2. Before I do that, let's make sure I have. All right, cool. So we're only going to send this Control C here. So what that did is the World 1 at the top, that was the leader. Notice World 2 went down. And then everything that was on that zone, or on that node, just got spun across the cluster again. We can see right here, session recovering. This is all a player will see during this like horrible thing of a full node dying. Also kind of cool, we got to see this is the world cluster being spun back up. These were the rooms that were online when the command to look again. So if we do this again, it's fully back, right? But it's always cool to like spot it in action. Yeah, so then we can bring it back. It'll rejoin the cluster. It'll be asserted on for the leader of World 1. We can double check this, right? So World 2 is back as a follower of World 1. And then if we do this top one, if we kill the top one, it looks like World 2 might have just been voted the leader. Phoenix should detect that the connection died and reconnect. We're just going to pretend that worked, though. Whoops. Oh, right, because I was going directly to this one. Okay, helps if I use this. There we go. It's sort of working. Oh, right, yes. Okay. There was a reason I was going directly to it. Traffic is trying to load balance to the dead node half the time. Yeah, so anyways, cool. So let's try this again, maybe, now that we're actually going through traffic. So we're on World 2, so kill that one. That one is the leader, right? World 1 might have just won. There we go. So now Phoenix retries enough that it'll work again. We'll hit the zone that's a node that's online, and that's the full amount of like error handling that the user will see on their end. So yeah. And wrapping up, this is ExVenture has a Discord. There's a few people there that are learning Elixir and whatnot. So if any of this looks interesting and you're starting your Elixir adventure out, there's a link here. The Discord link is also on the README for ExVenture, since this is kind of weird to type out real quick. Here's the image credits. And then, yeah, thank you.
Thank you, Eric.
Yeah, and one last thing, I have stickers for all of these, so if you want an ExVenture sticker, a Gossip sticker, or this is my cat, Odo, come find me.
Cool. Any questions?
A framework, or I guess, how did you approach doing those simulated load testing? And
The
real traffic, like, how did you simulate actual activity on the
Oh, right.
cluster?
So how do the bots work? So I started a little venture. I'll just go here. Oh, and I don't have internet. So it's a venture bot. It was on my GitHub repo or profile. So it is it's just a small little OTP app it just spins up a bunch of these clients. So when you start, I think it tries starting 50 by default, so it just adds a process for each client. And then you can say in IEX, just like add 50 more, add 500 more, whatever. So it just does, it's Gen TCP, I think. Yeah, Gen TCP, so when it starts up, does the handle continue and then tries to connect, and then just has a bunch of fun regexes to see what's coming in to know what to send next. So it's pretty stupid, but it does its job. And that's VentureBot.
Hey, I was wondering what you do, like what deployment looks like, given the whole leader election and rebalancing process. Do you try to avoid, like if you're, yeah, how does that work?
Yeah, so I have a release script. This is the most simple that could be. So I have this release script that dumps everything in static, builds it, digests it, release it. And I had some weird issue where the production release was screwing with dev, so I just delete it and build for dev again. But and then I have an SCP script that's not on this machine, so it just takes the version, SCPs the tarball up to all 3 machines, and then after that I do pretty much this, where I have 3 SSH panes, set them to synchronize and then start or stop, wait for them to die, undo the tarball, start, and then yeah. So it's by hand right now.
Have you have you experimented with hot code loading? This is just a lot of like process state,
Yep.
and I think that'd be really interesting.
I haven't. The Phoenix development stuff, anytime I'm messing around with game processes, sometimes we'll just completely tank the whole thing, and then, so I was like, I know I can make it work, but I don't care yet.
At the beginning, you talked about switching to a global registry.
Mm-hmm.
Did you look into anything like Horde or Swarm or anything, or were those two overkill for what you needed?
Yeah, so Horde was after I had done this, but I did try Swarm. There was a very surprising feature of Swarm that I wasn't expecting where, I have another fun thing is I have a command that can crash stuff, so I can just go ahead and crash the room that I'm in. And so I was trying that out with Swarm, and it ended up rebooting the entire world because one thing like died. I was like, ooh, I don't know what this is. I'll just go with global. So yeah, yeah. But if you're doing like thousands of processes a second or whatever, then that's probably the better way to go.
Yeah, can you get the mic right there?
I have a question about, I guess, some of the tools or processes you use for kind of debugging. Like there was mention about process state, and then there's a lot of information that's going on. And kind of I think you have a blog, right, where you talk about Venture. Do you ever go over the, here's what I experienced and here's how I fixed it type of thing? Because it'd be really interesting at a scale of this multi-node stuff to debug that.
Yeah, so I try and do either through ExVenture, Gossip, or so here's Gossip, so you can see what games are online, and then a new thing called Grapevine. So I've got a lot of open source stuff, and I try to do an update post at the end of the month that's just kind of general, and then a technical post. So Gossip does WebSockets and whatnot, but it does Cowboy WebSockets instead of Phoenix, so I did like a whole how to do that type of thing. So yes, I guess, to your question.
Thanks.
Cool. Any other questions? Oh, one more, okay. Can you reach out?
How long did it take you from deciding to go multi-node to having a multi-node prototype up and running?
Yeah, so that was a week of evenings, going from I have no idea what this is, to connecting clusters, to reading the Raft library or PDF, which is honestly was most of it. It's 10 pages, but it's 10 like dense pages. So yeah, so from start to finish of just anything working was about a week.
Thanks.
On the distributed part, when you were doing your research on how to solve the problem, were you looking at what's already out there in the Elixir world, or were you more focused on what the Erlang guys have already built, or how they approach the problem?
Yeah, so I'd read a book called Designing for Scalability with Erlang, I think is what its title is, something along those lines. And so that was kind of my biggest basis of like what to do, which is obviously all Erlang stuff. And I'm not sure, like a lot of cool distributed stuff has like popped up after I had started, so I just went for the base Erlang stuff since it was already included, right?
Okay, everybody give it up for Eric.